So, vertex form is the easier way of graphing this. So, vertex form of a quadratic equation, y equals a parentheses x minus h squared plus k. The first blank, okay, blank is the vertex, blank is the axis of symmetry. So this right here is going to be h comma k, where the second blank is going to be x is going to equal h. So it's x equals because, if you remember, axis of symmetry is going to be a vertical line, and a vertical line is x equals. Now, if you come over here, right, some little key points over here. For h, you're going to, when you pull it out, you're going to pull, when you pull out of the equation, you're always going to take the opposite sign. But for k, you're going to keep the sign. Okay, so k for keep. Right? So for number one, axis of symmetry. Okay, axis of symmetry. So it's going to be -4. And your vertex is just going to be -4, comma, -2. Yes, it's seriously that easy. So for axis of symmetry, +3, your vertex is going to be +3. There's nothing out here for k, so it's 0. Okay, for number 3, take the opposite, 5. Your vertex, 5, comma, -4. These two things have to be the same. Have to be the same. Okay, so for axis of symmetry here, because there's nothing in here with the x, it's going to be 0. And for your vertex, it's going to be 0, comma, 3. Okay, so now, how do we graph this? Well, graphing is so much easier with using the vertex form. Okay, but let's go over to this little area. Okay, you know for domain, it's always going to be all reals, okay, for the domain. The range, again, if a is equal to a positive number, okay, the range is going to be greater than or equal to. If a is a negative, then y is going to be less than or equal to. Okay? So axis of symmetry is going to be -2. Your vertex is going to be -2, comma, 7. Right? Your domain, all reals. Here's your A. A is negative, so it's going to be less than. There's your Y, so it's going to be 7. Okay, so we got to pause the video. Hopefully you guys can write this down. So let's graph the axis of symmetry. So it's at -2. Okay, there's that x equals -2. Our vertex is at -2, 7. So it's right there. How do we find our y-intercept? Our y-intercept is when x is 0. So we got to plug in 0 for x. So then we get y equals negative. We don't know why I have a plus comma there. Should be a plus. Okay, so we're going to graph the y-intercept, so it's 0, 3. So here's the origin, 1, 2, 3. What's the distance from the y-intercept to the
2.
axis symmetry? 2. So 2 that way, go over. There's my mirror image. Connect your dots. That is.
It is?
Yep. I know it's hard to see from back there.
Yeah, because it looks farther up.
Okay, there you go.
Why didn't we put anything why didn't we put anything in the chart for x and y?
Because my y-intercept and my vertex aren't extremely high.
Oh, but if they are, you use that.
You got it.
Okay.
Yes. And you would put your vertex in the center and go 2 up, 2 down type thing. Yeah, perfect question.
3, right? On
The y-intercept, yeah.
Is this the second part of our homework?
That is kind of like the first. What we're going to do now is, I don't think I need to do another problem in this respect. What we're going to do now is I'm going to show you how to kind of shove them different directions, which is kind of cool, and you won't really have to graph, find all this information, even though this is kind of a good way of doing it. So, with that said, if you need to pause it, to go backwards, look at it again, help yourself to do more homework problems, why don't you do that now, because we're going to go on to the next topic. Okay, so the most simplistic quadratic equation is y equals x squared. Okay, that's the very big baby one, although they don't call it the baby one. They call it the parent function. I will go back and forth, and I apologize. I will call it the mother graph. That's just how I am. Or the parent graph, or that kind of thing. The transformation is a change to the size or the position of a figure. Okay, so what we're going to do is we're going to take that parent function and we're going to manipulate it. We are going to move it left, right, up, down. We're going to make it skinny. We're going to make it fat. We're going to do all sorts of things to it. Okay?
Wait, I don't understand one sentence.
We're going to take that parent graph, okay,
Which graph?
y equals x squared,
Oh,
and we're going to take that and we're going to move it left, we're going to move it right, we're going to move it up, we're going to move it down. We're going to either go like this, we're going to make it skinny, or we're going to make it very fat. You'll see. That's what we do. Okay, we're going to try it. We're going to do this.
Wait.
Just write it down. All right, so what you see on the graph right there, okay, is the parent function. This guy right here is the parent function. That is the parent function. Yep. It starts at 0, 0. Okay, the vertex is 0, 0. The y-intercept's at 0, 0. And it goes up. It has a point right at 1, 1, negative 1, 1. Goes up, has another one. Okay, and it just keeps going. That is the parent function. Now, what's going to happen is you're going to take that parent function and you're either going to move it left, you're going to move it right. What are you going to do with it? Okay? I'm not. Oops. For the parent graph, this is the axis of symmetry. Okay? For the new graph that we're going to graph, okay, we need to figure out what the axis of symmetry is going to be, and we're going to try to manipulate the parent graph to see where it goes. Now, what's the axis of symmetry for this? Negative 2. So x is going to equal negative 2. What's the vertex then?
0, 0, 2.
Negative 2, comma 0. All I did was look at the equation, right? and pull out information. That's all I did. So if that's the case, I'm going to have my axis of symmetry right here for the new graph, correct? Yes? Because of that. Yes? Okay, so the vertex for this one is going to be -2, 0. Okay? -2, 0. Now, watch what happens. Watch what happens. Here's where the paragraph was, right? Correct?
Yeah.
Here's where the new graph is. What did we do to the paragraph to get the new graph? We moved it to the left. How many?
-2.
No, we just moved it twice. The vertex moved 2 to the left.
The original graph with the block one?
Uh-huh. So the vertex moved 2 to the left. Every point will move 2 to the left. So look what happened. Because it was a +2, we shifted left. I wonder what would happen if it was a -2.
To the right.
Shift to the right. Positive would go to the left, negative would go to the right. So if it's a positive inside here, it would go left. If it was a negative inside there, it would go right. Remember, it comes out the opposite. That's why. It always comes.
Would it be the other way around?
If it's a +2 in there, it came out as a negative, right?
Oh.
If it was negative in there, it comes out as a positive. So what would be right here?
Left
Transformation. It moved
to the left.
left. Thank you. Couldn't think of it. 2 units. That's what you would write. The graph and that. Go ahead.
Okay, I don't get why you did the lines already. Like, you didn't figure out the other points to go on the sides, but yet you already still did the lines up. Is it because it's right?
One, I had the capability of drawing it, but 2, you could do the y-intercept with this one.
Do
So
you have to?
what we could do is we could plug in 0 for y. For x. So we could find the y-intercept. Please watch, everybody. So we would do 0, something. Okay, this will get you your 2 other points. Okay, so we would do y equals 0, I did it again. 0 plus 2 squared, which would be 4. So then we would go over here. 4. Look at that. Even with drawing, it kind of worked. So we're how far away? 2, 2. And then you could connect your dots.
Oh, but because it was positive, you just needed to go.
I drew it. If you noticed, I was drawing it, like I was tracing the other
Yeah.
one perfectly, and that's why I was able to do it. But you would,
Okay, but before that, it looks like it had already been drawn on. So
the actual paragraph was drawn on.
Yeah.
So when you print these out at home, they'll be drawn on there.
So when it's positive, it's going to the left,
Mhm.
and when it's negative, it goes to the right?
Yep.
Like, from the original or from the new one? Like, because the
From this, what you see. So from here, because it's a +2, you pull it out, it's a negative, it'll go to the left. If this one says negative, it's going to go to the right.
Okay.
Okay, but with that said, let's go to this.
Oh.
And I'm going to give you a little key. and it'll make it all better. Okay? So how about you guys stop and watch, and then I'll let you guys fill it in. Okay? How about if you just watch me? Don't write. Let me just, you guys watch me, because then everybody else can just pause it. Okay, and you guys can write it. Okay, so, okay, you just learned about H. H goes which directions? H. Left, right, up, down, left or right, correct? So if H is blank, so does H, so if I go this way, it's, I'm sorry everybody, you're not seeing this on the video, but if, okay, it doesn't work because you guys aren't going to get it. Horizontal, there was no way for you guys to, so if it's a positive shift, it goes,
Right.
and if it's positive in there?
What?
Oh, it's positive.
It's
If
opposite.
it's negative, doesn't it go
Positive
right?
inside, it goes left. Remember, it's opposite. Negative inside, it goes right. Remember, it's opposite. It's inside. Remember, guys, if it's positive H inside, it's left. Negative. If it's K, it's vertical. This one's true to the actual signs. So if it's positive and it's vertical, it's going to go up. If it's negative, it's going to go down. Okay, so if A is negative, the function is and then with A, the active value of A greater than 1, and then if A is between 0 and 1. These are something you need to actually pay attention to. Okay, so I think this one I can get you guys to respond better than that one. This right here, if I've got 0, if 0's here and 1 is here, what are these numbers in between 0 and 1? What type of numbers? Decimals and fractions, right? Real small things. Yes, that makes sense. These types of parabolas, when they're graphed, I call it, they get fatter, they get wider, they get really, really, because what happens is you start at the vertex and they go out really, really, really slow. Really slow. Okay? Now, what happens if A is greater than 1? What kind of numbers are they fractions? They can be, but are they, they're bigger than 1, right? Yes? Are they small fractions or decimals? No, they're bigger. They can be bigger decimals and bigger fractions, right? Right? Think of pies. You can have a whole pie, a pie and a half, 2 pies, and so forth. This is where you're going to represent a vertical stretch. It's going to get, oh Lord, what do I want to write here? They're going to stretch. I don't want a steeper. Is that right? Yeah?
No, isn't it you? No, that would be.
You guys need to help. Two
Yeah, I think it's 2.
That's why I'm a math teacher. Just kidding. Is that right?
Yeah.
Ashton will correct it if it's wrong.